Okay, so we're looking at, in this video, the fact that there is another way of working out our equation for a straight line. This one comes in particularly handy when you've got quite more kind of difficult fractions in your gradient, so if your gradient's like 5/4 or something like that. And the equation is y minus b is equal to mx minus a. So this comes from our gradient equation. It's just rearranging it a little bit, changing a few of the letters. But this is where we have, this one works with one coordinate, which we have in the form a, b. So that with this one, finding our y-intercept or our c is a little bit kind of easier. There's not separate steps. We just kind of substitute in and then break our brackets and solve it that way. So let's have a look at this one. So we're going to solve and find the equation when we have coordinates, which are going to be 7, 11. So we're finding the equation through a, which is 7, 11. Oh, don't know what's going on with my Apple Pencil here, sorry. And keeps skipping bits. B, 9, 10. Right, so when we're doing these equation of a straight line, our first step is always the same, and it is finding m using our gradient equation, which is m is equal to y2 minus y1 all over x2 minus x1. So we've got 7 and 11, which will make x1 and y1, and then we've got 9 and 10, which we'll call x2 and y2. So on here, we're going to have 10 take away 11 on the top, and on the bottom, we've got 9 take away 7. So 10 take away 11 minus 1, 9 take away 7, 2. So our gradient is negative 1/2. So using our new formula that we've got, so we've got y minus b is equal to mx minus a. So we can pick any of the coordinates to be our a and b, it doesn't actually matter. So we could pick, in this case, let's go with 9 and 10, and that becomes our a and our b. So when we're doing this, x1, y1, x2, y2 is for the gradient, and then we pick one which becomes a and b for y minus b equals mx minus a. So substituting in, again, our x and our y stay because it's not an equation of a straight line without them. So we get y take away 10 is equal to minus 1/2 for our gradient, x take away 9. So when we're doing this, we're going to have to multiply out of our bracket first. So we've got y take away 10 is going to be minus 1/2 x, and then negative 1/2 times negative 9 becomes plus 9 over 2. 9 halves, because we're doing 9 times 1/2, so it's 9 halves, which is 4.5, but we're going to leave things as fractions, because fractions are our friends, and in National 5 we really need to work with fractions rather than converting everything to decimals all the time. So then we need to add 10 to both sides, so we have y equals minus 1/2 x, plus, and then we've got 9 halves, add 10, so 10 would be 20 halves, so we've got 29 halves, which we could convert to be 14.5, but we're actually going to leave it as minus 1/2 x plus 29 over 2. So we can see with that formula that we've got there that our equations of straight lines kind of can get a little bit more complex. They're not as nice as the very simple ones that we were looking at right at the start. And as a result of this, we actually have a way that we can make them look a little bit nicer. And that's what we're covering in the next video.